Hello everybody, welcome back to my channel. In the previous video we saw up to KVL, KCL, all of that. Today we'll be beginning with current division rule. So simple, current division rule is applied in parallel condition. Just think, when is current same? In series. But we want currents not to be same, that's when we can apply it, right? So that is going to be in parallel condition. Similarly, voltage division rule means voltage should be different. Voltage should be different means it should be in series. That's how you can remember it. So quick diagram I'll draw. This is obviously going to have a current I1 and R1. This is going to be I2, R2 and I total. Okay. So we can apply only when two resistors are connected parallelly here. So we want to know I1, that is going to be I total into opposite resistance by R1 plus R2. And I2 will be I total into opposite resistance by R1 plus R2. Or you can just write I2 is I total minus I1 also you can write. Remember, in current division rule it is opposite. It is opposite parts resistance which we are considering here. Okay. Now let me go to voltage division rule. I said voltage division rule, we take it in series. This is going to be R1, R2, R3 having V1, V2, V3, correct? Now V1 will be what? V total, some supply V will be there, that's going to be V into R1 by R1 plus R2 plus R3. Notice how here we take V1 means R1 only. We are not taking R2 or R3. No, we're taking V1 is here, R1 we're taking. Similarly, V2 means VR2 by R1 plus R2 plus R3. V3 means VR3 R1 plus R2 plus R3. That's it. Current division rule, voltage division rule, hope you understand. I'll quickly write once again here. For current division rule, I1 means I total into opposite path resistance by R1 plus R2. If I2, then I total into R1 by R1 plus R2. For voltage, V1 means V R1 by R1 plus R2. V2 means VR2 by R1 plus R2. That's it. That is all current division voltage, and that's it. Now let's quickly go and start with solving numericals. Let's start. Let's start with this I call it descriptive questions. Okay, I will read the question, but apply the data only which is required. Previous one we had on to question number 6, and I'm starting as question number 7 from here. So circuit of two parallel resistors having resistance 20 ohm and 30 ohm. First, let's write the data. Diagram draw, however you understand, not an issue. A circuit of two parallel resistors, okay, having resistors 20 ohm and 30 ohm respectively, connected in series with 15 ohm resistor. Now this is in series with a 15 ohm resistor. If the current through 15 ohm resistor is 3 ampere, now current through 15 ohm means you have to understand, for sake of it I'll just draw this side so that you can understand the flow. Either ways it would be working 15 ohm. Now the current passing through the 15 ohm resistor is 3 ampere. Find the current, you have to find current through 20 ohm resistor, current through 30 ohm resistor, total voltage across the whole circuit, total power and power consumed in all resistors. So it's a big question. Now why did I write 15 on this side? Just because you're conveniently following the arrow from left to right. That's why I just showed this. Otherwise also you could draw the arrow from the side. It would have mattered. Now current through this is 15 ohm we understood. Now we have to find the current through 20 ohm and current through 30 ohm. So we again edit as I1. I will take this as I1 and I2. I1 I can edit as I total into R2 by R1 plus R2, and I2 can write as I total into R1 by R1 plus R2. In current only we are taking opposite path. Okay. So that is going to be I total is 3 ampere here, because 3 ampere current only will go through this also. Correct. So 3 into 30 by 50. Here it will be 3 into 20 by 50. That is going to be what? Let me quickly use the calcium. This is going to have 1.8 amperes, and this will, you can either do 3 minus 1.8, it should give you the same answer, or you just do this 1.2 ampere. Okay, so current through 20 ampere, current 30 ampere is done. Now voltage across the whole circuit we have to find. So how are we going to find that? First let's try to find equivalent resistance. So first parallel, I'll do this RP 20 into 30 by 20 plus 30. I will get 12 ohm. 12 ohm plus a 15 ohm. So R equivalent will be the 15 ohm, can you see, right? 12 ohm plus 15 ohm. That will give me 27 ohm. Now we want V equals to IR. Total current also is given 3 ampere. That's the total one. So V equals 3 into 27. 81 volts is the total voltage. Now I have to find the power consumed. So P equals V into I. So 81 into 3, 243. This is the total power consumed, because total current is 3 ampere. Total power consumed also I can write it as this. So 243 watts is the total power consumed. Okay. Now I have to find the individual power. Individual power, I say P equals to I square R. So power through 20 ohm resistor will be what? 1.8 square into 20. That will be 64.8 watt. Now power equals to I square R. So power flowing to 30 ohm will be what? 1.2 square into 30. That is going to be 43.2 watt. If I do 64.8 plus 43.2, I should get, wait, it's a mistake. Oh no, one more also is there. 15 ohm also is there. Correct only. So power flowing through 15 I had forgotten. So I square R, that is going to be through 15, 3 is flowing. Yes, total current is only flowing. So 9 into 15. That is going to be 135 watt. So 64.8 plus 43.2 plus 135 should give me 243, which is the total power. All of this is equal to 243. I think this sum, yeah, now it's clear. So this is how we solve this question. So what did we do? The question was easy. We have to find I through 20 ohm, I through 30 ohm. That we understood it's a parallel circuit. So we used current division rule. We found a total voltage, that is normal equivalent resistance type question. It was I was given, R equivalent was there, so we could find V equals to using that formula, V equals to IR. Power we had to find. Total power is different. Power consumed by each resistance means you have to find using the current. Total power we have to use V into I. For each power consumed by each resistance, they have asked consumed by all the resistors. Then individually you have to put the I value, individually the R value, and then you have to find out. Okay, this are all descriptive questions basically. Now let's go to the next question. Question number 8. This is 3 ohm, 10 ohm, 6 ohm, 1 ohm, that is 9 volts. This again 8 ohm and 8 ohm. So what are we supposed to find here? I think we're supposed to find the current. If I'm not wrong, we're supposed to find the current. Okay. This is a simple question, nothing complex, nothing. This is normal what we saw, that only. I can see that we can solve this first. Anything else we cannot. So I'll start with RP1. So RP1 also equivalent resistance I can use. So 8 by 2, so 4 ohm. Let's redraw. Now I can solve these two. So 10. So RS1 I will write. Redraw again. 1, 9. This is 3. These two are in parallel. Yes or no? Because you can see a division here. So parallel. So again RP2 I will write. So 5 ohm, that become 10 by 2 5. N equivalent resistance in parallel formula I've used. Again read the circuit. You can see the number of steps are I'm writing almost decreased because I have understood how it works. 3, 10, 1. Now don't think this is parallel because the voltage is coming between. No, doesn't matter. It's still going to be in series only. Correct? So 10 plus 3 plus 1. 14 ohm is the, one second, this is 5. I forgot to change it. So 5 plus 3 plus 1. 9 ohm. So that is the equivalent resistance. We have to find the current. So V equals IR. So V by R, that is equals to 9 by 9, that is 1 ampere is the current. That's it. Easy question, isn't it? Now next question, let's do the next question. Question number 9. A current of 20 ampere flows through two ammeters A and B in series. This A and B are two ammeters which is in series, and the current flowing through this is 20 ampere. The potential difference across A is 0.2 volts. The potential difference across B is 0.3 volts. Find how the same current will divide between A and B when they are connected in parallel. Now first let us treat this as resistance. Okay. First, can we find the current flowing individually through this? Here voltage is different. Voltage is different in where? In series. Okay. So voltage is different. Current is same. Wait, one second. I will tell you. 0.2 by 20 you do. You will get 0.01. That is the resistance of this. Yes or no? Now again V equals to IR. This is 0.3, 20 R. 0.3 by 20. 0.015 ohm. That is the resistance of this. Resistance we got. Now when they are connected in parallel, now also 20 ampere current is flowing, mind it. So now we have to find the current, which is find how the same current will divide. Now I 1 equals 20 into 0.015 by 0.01 plus 0.015, current division rule. 20 opposite part, 20 into 0.015 by 0.01 plus 0.015. I will get 12 ampere. And I2, we did not even find how the current is dividing in series. We only found the resistance. They didn't ask us to find how current is dividing in series. That's how current is dividing in parallel. That's fine. Now either you can 20 minus 12, 8, or just for showing I'll show you 20 into 0.01 by 0.01 plus 0.015. You will get 8 amperes. That's it. It looks hard because ammeter, all of that is involved, but take it as a simple concept like this, you will find it easy. And the next is based on unknown resistor calculation. We have to do based on unknown resistor. So let's start with that kind of questions. Sorry, my bad. In the beginning, I told you by mistake that we have finished KCL, KVL in the previous video. It was by mistake. We have finished solving basic problems in the questions. I think I've made a mistake of thumbnail as well. I don't mind it. But yeah, we're covering anyway in the video, so I don't think that should bother much. Let's start with the next concept, which is unknown resistor. I suddenly remember, so thought I should say. Unknown resistor problems. I'll try to finish this here, and in case of KVL, we can start in the next part 3. Okay. So here, what will be done is there will be some hint given in this question. I will show you with the question itself. So question number 10, this is going to be. You can see the question. Unknown resistor means you have to find the value of the resistors whose value is not given. Eight volts. I is flowing. 4 ohm. This is the resistor whom we have to find. 2 ohm, 8 ohm. Now the hint to see the total power is 16 volt. We have to calculate I total and unknown resistor value also have to calculate. So firstly we can see that let's first P equals to VI. So 16 equals 8I. So I total will be 2 ampere. Very direct. We didn't do anything itself. You would have imagined we have to find the resistance and each resistance. Nothing, totally nothing. We just have to do this. Total power is what? Total current means you have to find total power by voltage. 2 ampere we got. Fine. Very good. Now we have to find unknown resistor value also. Let us find that now. First let's solve IP1, IP2, all of that. RP1 equals 4 into R by 4 plus R, and RP2 will be 2 into 8 by 2 plus 8. So 16 by 10, that is 1.6. So I will write it as 4R by 4 plus R and 1.6. It's an 8 volt. I have to find the value of that. So V equals IR if I use 8 by 2 should be equal to 4R by 4 plus R plus 1.6. So, are you able to understand what I'm doing? Yeah. So, 4 minus 1.6. 2.4 equals 4R by 4 plus R. So, I can write it as 9.6 plus 2.4R equals to 4R. So, 4 minus 2.4. So 9.6 equals 1.6 R. So unknown resistor value will be 9.6 by 1.6. That is going to be 6 ohm. Basically, this series, right? So that's why I added this. V equals to IR. So that's why I wrote 8 by 2. Was it understandable? You can use P equals to V squared by R formula also, because there is a total power formula. This also you can use. I just choose this. Okay. I hope this question was easy. I hope I didn't overcomplex it. This is easy. First, you should get that thought of using this. Otherwise, you will be stuck in the loop. How? Okay, let's go to the next question now. I'll just add some pages. Yeah. So, question number 11. This is 12 volts, 8 ohm, R ohm, 4 ohm, 16 ohm. Now, what should we find in this? Again, what is given is P total is 18 watts they have given. We have to find I and R value. I total basically. So, let's start. Firstly, again, total I we can find directly because P equals to VI, we know that. So, 18 equals 12 into I. I value we can get easily. 18 by 12. That is 1.5 ampere. Now for finding this one, so RP1 I will consider this and RP2 I will consider this. So RP1 will be what? 8R by 8 plus R. RP2 will be what? 16 into 4 by 16 plus 4. So 16 into 4 divided by 20. That will be 3.2 ohm. So P equals to V equals to IR. We have to find the value of R, right? We know is 12. This is 1.5 and R is, now series will become. Do you want me to redraw it? I'll just redraw it and then I'll erase it. Okay, 8R by 8 plus R, and this is going to be 3.2. This is going to be 12. So you know it is in series. So this is going to be 8R by 8 plus R plus 3.2. So I'll take 12 divided by 1.5. That's it. That's going to be 8 equals, I minus now only 8 minus 3.2, 4.8. I'll just minus now and get the final answer. 4.8 equals 8 R by 8 plus R. 4.8 into 8, 38.4 plus 4.8 R equals 8 R. 8 minus 4.8, 3.2. So 38.4 equals 3.2 R. R equals 38.4 minus 3.2. That is 35.2 I am getting. Let me cross check. Not minus, divide. So 38.4 by 3.2. R is 12 ohm. So 38.4 equals 3.2 R. This is how you solve. Same type as previous question. It was exactly the same type as previous question. I hope you understood this question. Let's move on to the next one. Question number 12. Look at this question. It's slightly different. This is 8 ohm. This is X ohm, which you have to find. This is 40 ohm and this is 25 ohm. The total current flowing through this is 4 ampere, and through this 2.5 ampere is going to flow through this I2, through this I3, through this I4. In a parallel arrangement of resistors shown in the figure, current flowing in 8 ohm is 2.5 ampere. You have to find the current flowing resistance is I2, I3, I4. Unknown resistance value is X ohm and equivalent resistance as well. So if you see the question directly approach, you will not get. So again, build slowly, okay. So one thing which I understood that is parallel. To find the unknown resistance value. So what can we do is we can find these three. So potential is given. No, it's not given. Okay. Okay. Just now I saw and I got the idea. Potential. This is a parallel. So potential is going to be same. So we don't have to take individual resistance and find because potential also V equals to IR. So V equals to 4 into, sorry, not 4, 2.5. See, I'll tell you. Just give me some time. I'll tell you now. The thing is, all lasers are connected parallelly, so potential is same. But calculating potential, you should, for total potential, if you would know, and if you would divide it by total current, you would get resistance. But to find the total potential, don't take the total current value because you don't know total resistance value. If you know the total resistance value, then you could have taken total current value. But do you know total resistance value? No. So take any one of the known resistance and known current. That is going to be the first one. Because we have to proceed means we need a voltage. So it's going to be 20 volts. Okay. Okay. Now we can find easily V equals to IR. 20 equals I3 into 40. So that's going to be 20 by 40. So I3 will be 0.5. Similarly, 20 equals I4 into 25. So 20 by 25, that is going to be I4 equals 0.8. Now we have 4 equals 2.5 plus I2 plus 0.5 plus 0.8. I2 value will be what? 4 minus 2.5 minus 0.5 minus 0.8. That is going to be 0.2. Now V equals IR. 20 equals 0.2 into X. So 20 by 0.2, that is going to be 100 ohm. That's it. So did you understand what did we do actually here? 20, now I have to find the equivalent resistance as well. So that is going to be 1 by R equivalent equals to 1 by 8 plus 1 by 100 plus 1 by 40 plus 1 by 20. I almost forwarded until I saw the solution. So it's very important that you read the question again and again. So 1 by 8 plus 1 by 100 plus 1 by 40 plus 1 by 20. So I'm get 1 second. I think I've made a mistake somewhere. No, it was correct. So 1 by 8 plus 1 by 100 1 by 100, just give me a second, 1 by 100 plus 1 by 40 plus 1 by 20. Guys, 1 second, I think I've made somewhere a mistake. 1 by 8, 0.125, 1 by 100, 0.01 plus 1 by 40, 0.025 plus 1 by 20, 0.05. Now 1 divided by 0.125 plus 0.01 plus 0.025 plus 0.05. So it's 1 by 25. That is what I've been making mistake. Now I get the correct answer. Oh my god. The whole question has gotten over so fast, and this last part we have taken so long. My bad, guys. Yes, now we got 5 ohm as the equivalent resistance. Now if you want to cross check as well, you can do V equals to IR. This is 4 into 5, 20. That's what we took as initially. So either you take the whole total current into total resistance, or total into one of the resistance into one of the current. Do not take one of the resistance into total current. I will mess up. One of the resistance into one of the current, or total resistance into total current. So this was the entire answer. It was not too hard. We didn't have to use any of the current division or voltage division. Nothing we have to use. It was simple. Sometimes we see the problem and think, maybe this we are using here, maybe this we are using here, but actually nothing. So question number 13 we will solve. A resistance R is connected in series with a parallel circuit comprising of two resistors, 12 ohm and 8 ohm. So there's a resistance which is R, which is connected in series with two resistors which is connected in parallel, 12 ohm and 18 ohm. The total power dissipated in the current in the circuit is 70 watt. Calculate the R when applied voltage is 20 volts. So 20 volts is also there. So P equals VI, 70 equals 20I. So I total current value first I'm calculating 70 by 20, which is 3.5. So the current flowing through the circuit is 3.5 ampere. Now let's find this part. RP1 equals 12 into 8 by 12 plus 8. So 12 into 8 divided by 20, 4.8. So V equals IR. So 20 equals 3.5 into R plus 4.8. So 20 equals 3.5 R plus 4.8 into 3.5. That is 16.8. So 20 minus 16.8, that is giving me 3.2 equals 3.5 R. So 3.2 by 3.5, that is giving me R value as 0.91 ohm. Okay. Did we understand this? We can use P equals to I square R also, I think. But okay, I've used this and I've got the answer. But I think P equals to I square R would also... Okay, this also is fine, that also is fine. So the next part I will continue in the next video. See you on the next one. Thanks for watching. Bye bye.